Alright, so jumping right in here, 1.2 notes, measuring segments. We're going to use some algebra review that we've learned the last few days. But the distance between any 2 points is the length of the segment between the 2 points. So distance is really just another name for length. And we have a number line here with some red dots on there. And let's do example 1 and try to kind of highlight what I'm talking about. So part A, find the length of BC. So first of all, whenever you see notation like this, you'll notice the BC does not have a line over it. There's a difference. So when you have BC with the segment mark over it, this is read as segment BC. All right, we're talking about the physical segment. We're talking about this piece that goes from here to here, that actual segment of the line. But when you see BC written this way, with no notation above it, this actually refers to a number or the length of segment BC. So we look at this line, and the distance from B to C is 2 spaces. So BC equals 2. Moving down to part B, AC, what is the distance from A to C? So I'm going to get rid of BC here, and I'm going to do this one in red. So the distance from A all the way to C, a couple different ways you can do it. You could count spaces, 1, 2, 3, 4, 5. So AC equals 5. Or you can just use subtraction. You can use the 2 coordinates, and as long as you subtract the larger coordinate minus the smaller coordinate, so 3 take away a -2, you'll also get 5. That's handy when the numbers are a lot further apart and counting spaces is a little too tedious. Moving on over here to example 3, xy, so the distance from x to y, I'm going to use a subtraction method. It's 5 take away, and this red dot right here looks like it's at 1.5. So 5 take away 1 is 4, take away another half, it's 3 1/2. And the last one, the distance from x to z. So x to z represents this portion of the line. A little bit tougher because we have some negatives in here, but let's just use the subtraction method again. So I have 1 1/2 subtract a -3. And whenever you subtract a negative, you really add the opposite. So this one comes out to be 4 1/2. So not too bad finding the distance between 2 points on a number line. Pretty straightforward, just using subtraction. Alright, let's scroll on down here and talk about congruent segments. Congruent is a vocabulary word we use quite a bit here in geometry. So congruent segments are segments that have the same length. This is the key part here. Congruent means same length when you're talking segments. If we're talking angles, congruent angles are going to have the same measure, the same number of degrees. So in a diagram, let me just kind of draw this, and I'm going to draw a segment PQ. So there's segment PQ, and then I'm going to draw another segment right here, the exact same length, or I'm going to try to about make it the same length, RS. And since, if I know that the distance, let's just say that the distance from P to Q is 7 inches, and the distance from R to S is 7 inches. Since those two are equal in length, I can say that not only is the distance from P to Q equal to the distance from R to S, okay, that's a statement saying that their lengths are equal, but I could also write it this way and say that segment PQ is congruent to, it's kind of an equals with a little squiggly up above, or a tilde from Spanish. Segment PQ is congruent to segment RS. So this symbol right here is our congruent symbol. Basically, you can just think of it as meaning equal. It's kind of the same thing. Now, we also sometimes, if we don't want to have to write out statements like that, we can say that we can use tick marks in a diagram. So a tick mark basically looks like this. You just kind of put a little tick mark there, a little tick mark there, and that shows that those two segments are equal in a drawing, and I don't have to write out the extra words. All right, so that's what congruent is. Let's scroll on down. And let's get this notion of between kind of figured out. So in order for you to say that a point B is between 2 points, all 3 points must lie on the same line, and this equation also has to be true. The distance from A to B plus the distance from B to C has to equal A to C. Now that doesn't really make a lot of sense here until we look over here at the diagram. So let's look at this segment addition postulate right here. So if B is in the middle, so we have B right here in the very center, not in the center, I misspoke there. In between just means anywhere in between A and C, not in the center, that's a special case. But if B is somewhere in between A and C, it should be true that the distance from A to B right here, when I add that to B to C, this distance right here, it should equal the entire line segment. So I kind of like to say that little plus little equals big. All right, that's going to kind of be my setup. And you can almost think of it like exits on a highway, you know, where one exit is kind of in between the other. Maybe A is at exit 100 and B is at exit 120 and maybe C is at exit 150. If I were to actually calculate the distances, you know, the distance from A to B would be 20 miles. The distance from B to C would be 30 miles. So the entire distance would be 50 miles from A to C, which makes sense because from mile marker 100 to 150 would be 50 miles. Now, a case that's not between, so in geometry, let's say that A is right here, and let's say that C is over here, and we connect those with a segment. If B is up here, we cannot say that B is in between A and C, even though it kind of seems like it is. To use the word between, it has to be on the same line as the other 2 points. So this case, this B here is not between A and C. Just to kind of get that out there. All right, so let's do example 2. We're going to have to do some drawing on our own. Let's first start off right here. Point G is between point F and H. So let's just draw that out. And you could put it wherever you want. It really doesn't matter. But G is somewhere in between. I'm going to just put it over here. G is between F and H. Now my drawing may not be to scale because I don't know the distances yet. If you really wanted to look ahead early, you could kind of look at the distances and draw it perfectly accurate, but a lot of times I don't really worry about that. So F to G is 6, so I label that right here on the line, and I put it right above it. So F to G is 6. F to H, the entire distance. So I'm going to kind of come up above and draw some arrows to show that it goes all the way from F to H. That's 11. So now they want me to find GH. So I'm trying to find this distance right here. Well, because of our equation up above, I know that, and I don't usually always write all this out, but I'm going to do it here the first couple times. From our segment addition postulate, the distance from F to G plus the distance from G to H, so the two little pieces, the left piece plus the right piece, should equal the entire segment. And now I'm just going to substitute the values. F to G is 6. We don't know GH, that's what we're looking for. And we do know the entire distance is 11. So I could almost solve this one like an algebra equation. I really don't need to be this formal. I think a lot of you could probably say, you know, hey, 11 take away 6 is 5. So now it adds up. But you could also do it using algebra. And I cancel that out, and I find out that GH equals 5. Totally unnecessary probably for this problem, but it's a little, it's kind of a good idea just to see the structure. So when the problems are a little tougher like part B, then we kind of know what we're doing. So part B, M is between N and O. They actually give me a picture here. So N is in between, not in the center, but in between. Find the distance from N to O. That's what we're after. So I'm kind of down here at the bottom. I might just put NO equals because I want to remember what I'm after in the very end. So I have a few players in the game here, and I'm going to write this out formally with algebra. The distance from N to M plus the distance from M to O equals the entire line segment, N to O. And now I'm going to start replacing people. So N to M, Well, that was 17. And the distance from M to O, that's 3x minus 5. And that should equal the entire segment, which is 5x plus 2. So all I've did here is I've just basically substituted what these values were for my diagram and plugged them into an equation. Now we actually have to do some solving, which is why we spent the first week doing algebra review. So I look at my equation. I notice there's some like terms here on the left hand side. This 17 and this minus 5 can be combined to 12. So 12 plus 3x equals 5x plus 2. And I see I have x's on both sides, so I need to get all my x terms on one side. I always like to attack the smaller x term, so I'm going to attack this plus 3x and I'm going to subtract 3x. I just like to make my x's positive in the end. You don't have to, but this is just my strategy. So I bring the 12 down and then I have 2x plus 2. So I have all my x terms on the right. I want to get all my constants or my number terms on the left, so I'm going to go minus 2, minus 2. And I got 2x equals 10. Now I'm going to divide both sides by 2, or in my head, 2 times what is 10? X equals 5. Now that's not the answer to the question. On a multiple choice test, they may have one of the answers as 5, but the ultimate answer is, how long is NO? So what I'm going to do now is I'm going to take this 5 and I'm going to substitute it back in, or here if you want to, either way, because that's the true distance of NO. So basically it's 5 times, I now know what x is, 5 times 5 plus 2, which is 27. And they don't tell me if this problem is inches or feet or whatever, so I could put units, but I'm not really going to worry about that. The answer mainly is 27. That's what I'm worried about. So that's the idea of between. The left piece plus the right piece equals the entire piece. That's kind of the idea. Let's move on to the back side of the notes. And now we get into a special between point, the one I kind of misspoke about earlier. And that is this idea of a midpoint. All right. The midpoint, which often we use the letter M because it starts with M. The midpoint of segment AB is a point that bisects, or divides the segment into two congruent pieces. I like to just think of bisect as chop in half. It perfectly chops it right down the middle. And if M is the midpoint of segment AB, then the distance from A to M equals M to B. I think this is easier to see with a picture. So let's kind of go back to this part right here. M is the midpoint of segment AB. Let's draw that. So segment AB, there's segment AB. And if M is the midpoint, that means it's smack dab in the middle. And I really don't know. I mean, this kind of looks like it's in the middle, but I really don't know for sure unless I measure it. And the distance from A to M, this distance right here, has to be the exact same as the distance from M to B. If these two distances are the same, then I know it's a midpoint. And I would say that M, so another way to describe this picture is to say that point M bisects segment AB. If that's true, then I know that M is, and a lot of times I just put MIDPT for short for midpoint. Alright, so we're going to use some algebra to solve a problem here. Example 3. If D is the midpoint of EF, well, immediately let's draw that. Don't even get caught up in all these other X's and numbers. Just draw that. D is in the middle of EF. And it doesn't always have to be horizontal. I just like to put it horizontal. It seems easier. So E in F is a segment. D is in the middle, so I put D right in the center. And since they told me it's a midpoint, I'm going to put the tick marks to show that ED is congruent to DF. And let's put some values on here. ED is 4x plus 6, and DF is 7x minus 9. And we need to find 3 different answers. We need to find how long is ED, the left segment, how long is DF, the right segment, and then the entire segment. So I'm going to have to use algebra, find out what x is, plug x back in, and then I can get some real numbers. So unlike how we set up the between problems, where I knew the left side, the right side, and then I was also given the total, and I did left plus right equals the entire thing, I don't really need that on here because I know that the left side equals the right side. So I can just set up an equation right now. Midpoint's actually a little bit easier than the between problems. So 4x plus 6, which this represents ED, is equal to the distance from D to F, which is 7x minus 9. And again, this line right here is kind of optional. You don't have to write that, but you definitely need to start with this one. And I'm going to start solving on it. So I'm going to attack x terms first. I'm going to go after the smaller x. So I'm going to go minus 4x minus 4x. And I end up with 6 equals 3x minus 9. And since I've got my x's on the right, I need to get all my numbers to the left. So I'm going to add 9, and I get 3x equals 15. And 3 times what is 15, or divide both sides by 3, and I get x equals 5. Now that I have x equals 5, I should be able to go in and substitute and find the answers for all the pieces. So let's kind of just come right back up to my picture, and we're going to put it in right there. And if I've done this right, I should get the same for both sides. So I go ahead and I plug that in, and 4 times 5 plus 6, I'm doing the left-hand side, I'm doing ED right now. That comes out to be 26, so this was ED. And I'm going to do the right-hand side, 7 times 5 minus 9, well that's 35, subtract 9, that's also 26. So it looks like my answer's checked out. ED is 26, DF is 26, which would mean the entire line, the distance from E all the way to F, okay, from the beginning all the way to the end, I just add up those two halves. So 2 times 26 would be 52. So that's the distance from E to F. Now, if you were to solve your algebra wrong, if somewhere over here something went wrong, and let's say you got like, x equals 4, which we know is not right, but just say that you did. When you plug it in the diagram, when you plug it in over here and over here, you would get two totally different answers. They would not be equal, so that way you know that you did it wrong. So you always want to plug it in, even if they don't ask for all of these values. They may just ask for x in the question on the test. Plug it in just to double check. Alright, moving into our last example here. Sliding down. Looks like it's another midpoint example. Try to keep this video a little shorter than 1.1. S is the midpoint of RT. Again, just draw that right now. Just stop. Don't try to keep track of too much in your head at one time. So RT is the segment. S is in the middle, which I know I can mark with tick marks. RS is a negative 2x, so that's a negative 2x. ST is a negative 3x minus 2. These look kind of weird because they have negatives in them. And same thing, find all the pieces. So I'm going to move a little bit quicker on this one. RS, the left side, equals ST, the right side. And I start solving this. Well, this one's a little different. I have an x term on the left, and that's the only thing there. So I'm going to get all my x's to the left. I'm going to add this 3x. I got to do the opposite, remember. Add 3x. And this cancels out. A negative 2x plus 3x is 1x, or just x, equals. And then this negative 2 slides down. So x is negative 2. Now you might be kind of uncomfortable like that. Well, I didn't really know I could have a negative for an answer. It's okay to have a negative value for x. When you plug it back into the equation, you shouldn't get a negative answer because distance has to be positive. We can never end up with a negative distance. That's impossible. You're either 0 or you're some positive number. So let's plug these in. So we're going to find RS, and then we're going to find ST, and then we'll add them together to get RT. So RS was negative 2 times x, which is negative 2 times negative 2, which is 4. So RS equals 4. ST is negative 3x minus 2, or negative 3. I substitute the value for x in there, subtract 2. So a negative 3 times a negative 2, that's 6. And 6 take away 2 is 4. So ST is 4. So that checks out. So RS is 4, ST is 4. And then I add those two together, and that will give me the distance from R to T, which should be 8. Alright, so a little bit more algebra today than lesson 1.1. Basically solving equations with variables on both sides. So let's come back tomorrow and let's get after it for the homework. Later.